All right, period one. So in class we went over this, and if it was at all confusing, you'll want to read this section of the physics classroom on momentum and impulse. And so with this, we went over the equation and where this equation comes from, and that this is equal to the impulse times the change in momentum, and solve the problem with this football problem right here. Now, the last thing we did was we looked at this vector diagram. So this is one way of representing motion with a physical picture of the scenario and vector arrows. Another way of doing it is with a velocity time graph, and then yet a third way is this dot model. You can see here that the initial velocities for case A and B are about equal. The dots are equally spaced on both sides. But here on case B, the dots are pretty far apart still, and here they're very close together. When they're very close together, it means the object's going slow. This would be like taking a tennis ball with a hole in it and throwing it against the wall. It's just kind of go splat and go boop, 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 very slowly off the wall. Versus if you threw something that was a better bouncer, like a tennis ball without a hole in it, or a racket ball, or a lacrosse ball, it would bounce off the wall with greater velocity. One thing you should see with all of these is that the impulse and momentum change are always the same. Getting down here, these are the key things you should know, the three major things, so you want to put those in your notes, as well as the stuff in red from up here that would want to go into your notes, these equations right here, and then this. And then down here, you should try to solve these problems. Now, I said in class that I want you to do all the problems. I don't. It's way too many. We're just going to stop with this chart right here. This is going to be your homework. So, to do this, I want you to notice that if we scroll back up, you see that the equation that we've learned now, or the equation we've come up with, says that impulse is equal to the change in momentum. And if we put that in terms of variables, it's force times time, which is the impulse, is equal to the change in momentum, which is mass times the change in velocity. So, keeping that in your brain, comes back down here to the chart. Notice, over here we've got force times time. What's that? Impulse. And over here we have mass times the change in velocity. What's that? Change in momentum. So the left-hand side of this is the impulse side, and the right side is the change in momentum side. And so, when you're solving these, whatever you get here for the impulse, you should get the same thing for the momentum. To solve this, we need to use this equation that we just had, which is force times the change in time equals the momentum times the change in velocity. I actually did this on the board in second period, and so I will show you right now what I did. Here we go. So, here's our given information right there. Hello. Can I make it? There we go. Quack, quack. And so we know the change in velocity. It's negative 4 meters per second times 10 kilograms. And so that's negative 40. That's the change. Sorry, that's the change in momentum. So that's the right-hand side of the equation right here. There we go. On the left-hand side, we don't know the force. It's over there. But we do know the time. And so we can plug that in. Now, if we want to solve for the force, we need to isolate force, so that means dividing both sides by negative or by 0.01. So we do that to both sides, and we end up with negative 40 divided by 0.01, which is negative 4,000, and that is the force. It's in newtons, and we would plug that in there. And if you click on See Answer, it'll tell you that's what the answer is. And then you can use that times this to figure out the impulse. Negative 4,000 times 0.01 is negative 40. We can also figure out the change in momentum right here, negative 40. So like I said, they're equal. You can do the same kind of steps for the rest of them, right? Figuring out what the unknown is and then isolating it, plugging in the numbers and solving, and you should be able to get all the answers without too much trouble. And again, the point here is for you to see that the impulse is equal to the change in momentum, that the impulse is equal to force times time, and that the change in momentum is equal to mass times velocity, or the mass times the change in velocity. So that's the goal here. And then we'll do some more stuff for this tomorrow. All right, thanks for watching.